So this is section 1, and we're going to start by talking about what a relation is, and then eventually we'll get to what a function is. A relation is just a set of ordered pairs. A set of ordered pairs. Now, we often think of ordered pairs in terms of numbers, but you can also have words or letters involved in an ordered pair. Mostly we're going to be using numbers, but you'll see some examples in this section where they use words to form ordered pairs. Okay, so a set of ordered pairs. I'll just make up a set of ordered pairs. So 0, 1, 2, 3, and 4, 5. So it's not a very exciting set, but there are 3 ordered pairs, and that would be a set of ordered pairs, therefore it's a relation. So when we have a relation, we often want to talk about the domain and the range. The domain is made up of the first components. So the first components, those are called the abscissa, but nobody uses that word. And so our domain is going to be the 0, the 2, and the 4. So I can write that as a set, 0, 2, 4. That would be the domain then, and I would list it because it's a finite set. I can list the domain. The range is the second component, or that's called the ordinate. And that would be, in this case, the second components, which would be 1, 3, and 5. 1, 2, and 3. Okay, so in a relation you have the independent variable, which is referred to as the input, and a dependent variable, which is the output. Now, you could have a relation like y equals 3x. So we've done that before in the past where we've had an equation. This is a linear equation, and we've graphed the linear equation. And maybe we made a table of values and we found some points, and then we drew a line. The line represents an infinite number of ordered pairs because there's an infinite number of inputs you could put in and an infinite number of outputs that would match. You could form those ordered pairs. It's still a relation. You have inputs and you have outputs, but it would be an example of an infinite set of ordered pairs. Finite relations, that's like the one we had up above, where we had 0, 1, and 2, 3, and 4, 5. That is finite because there's only 3 ordered pairs. I made up that relation, and those are the ordered pairs that I gave. When we have a finite set, we can make what's called a mapping. In a mapping, we put one, usually it's an oval, sometimes I'll use rectangles, but one oval to represent the domain, or the input, and then another oval that represents the output. In this case, our input was 0, 2, and 4, all the domain elements, and the output was 1, 3, and 5, all the range elements. And then we make the mapping by drawing the arrow from the input to the output that it goes with. So in this case, 0 is mapping to 1, 2 is mapping to 3, and 4 is mapping to 5. Each line arrow represents an ordered pair. Okay, so that would be an example of a mapping. Now you could have a mapping like this. 1 and 2, and then maybe over here you have 3, 4, and 5. Maybe 1 maps to 3, and 1 maps to 4, and 1 maps to 5, and maybe 2 just maps to 5. This would be a relation. It's a set of ordered pairs. There would be 4 ordered pairs because there are 4 lines. And so you could write the set as the ordered pairs 1, 3, 1, 4, 1, 5, and then finally 2, 5. That would be a finite set. There's 4 ordered pairs, and that would be a list then of the ordered pairs. It's a relation. You might ask, well, could I have something like this? 1, 2, and then over here the 3. and maybe 1 maps to 3 and 2 maps to 3. Yeah, that would be another relation. It's a set of ordered pairs. There would be 2 ordered pairs, 1, 3 and 2, 3. Okay, so those are some examples. Now we're ready to talk about what a function is. A function is when each input matches to one output. So in other words, on our mappings, we can only have one arrow come out of each input. Okay, now this definition is on page 2 in your textbook, so you can look that up. So this example right here, is that a function? Yes, this is a function. Because if you look at the inputs, 0, 2, and 4, each of them only have one arrow coming out. Now, what about our example over here? No, that would not be a function. Not a function. Because you've got one with 3 arrows coming out of it. So there's an input going to 3 different outputs, and so it's not a function. Now, what about this bottom one? Yes, this is a function. They're both going, the inputs are both going to the same output, but that's okay. We only have one arrow coming out of each input. Okay? Now, something that's going to come up in our next examples is this part. The output is a function of the input. So if you're doing ordered pairs in terms of x and y, we would say y is a function of x. Now, not everything is always in terms of x and y, but sometimes we do that in math. We have a Cartesian coordinate system. So that might be somewhat familiar to you. But the output is a function of the input. So just remember that.